In this video, we're going to continue our discussion from the previous video by discussing different types of variables that you may see. There's a couple of different classifications of types of variables that we'll discuss, but I'm going to just talk about two relatively basic ones. And we'll start with a bit of a more formal one and end with a bit of a less formal one. So the first regards the 4 levels of measurement, and these spell out an acronym NOIR or NOIR, representing 4 different levels which are increasing in the amount of information each data point has. The lowest level is considered nominal. This is just different categories that data can fall in, or excuse me, that data point can fall in. So for instance, a nominal variable might be favorite color, and the levels of that variable might be red, green, orange, blue. Now, what makes nominal different than some of the others is there's no inherent way to order that information. Other nominal variable examples could be your favorite pizza topping, your hair color, the color of the shirt that you're wearing. Let's get off of colors. Your favorite superhero, your name. These are things that we can record. Sometimes these are called categorical variables. We'll talk about that in a moment too, and are considered categories or groups that the outcome or participants may fall into. So that is a nominal variable. The next level of measurement is ordinal, regarding ordinal variables. What we add on, and each of these will add on one unique attribute to what the data are telling us, what we add on to this one is order. Now, within an ordinal variable, one key component is that the differences between each element in the data set might not be consistent. One of my favorite examples is ranks in the military. Now, in the military, you can move from a private to a private first class, and I am by no means a military buff, so I apologize. But a private to a private first class might represent, a couple of months of work, or maybe you graduated as an Eagle Scout or something like that and got this promotion. So that would be one movement bump. Now, this is different than nominal because if I write private first class, it's clear that a private first class goes after a private. So there is in some way an order, which is why this is called an ordinal variable. It's categories, but it has an order. The reason that this is limited is because, again, the difference between any two things are not necessarily the same. So, for instance, the distance between a private and a private first class might be much, much, much less objectively than the difference between a 4-star and a 5-star general, which may nominally only represent a single bump in rank, but represents a vast amount of work, potentially an impossible amount of work assigned only in wartime. So for these, our ordinal data represent, we can tell the order that things go into, but we don't always know that they have an equal distance or an equal interval between any jump from one to the other. So again, nominal, there's no order at all. There's no way to order the colors naturally. Ordinal, we do know the order that things go in. Private goes before private first class. Private first class goes before general. 4-star general goes before 5-star general. We can write them in order in a meaningful way, those levels of the variable. One very common ordinal variable that you'll see too, or something called a Likert scale, Likert, Likert. This is named after a prominent psychologist who was one of the first people to try to quantify qualitative, that is descriptive or textual data or experiences. And you'll see this represented by a strongly disagree to strongly agree on a scale. So you may see strongly disagree, neutral, agree, strongly agree. This represents ordinal data. Why is this ordinal? Because the distance between strongly disagree to just disagree is not necessarily the same distance as the distance between a neutral to an agree. What someone has to go through to get from one position to the other might be completely different in each of those categories. And so this typically represents ordinal data. The next thing that we add on after order, again, nominal, no order, ordinal adds order, is an interval. The interval type of measurement represents variables that have not just order, but also the interval between any two things is equally distant. A great example of this is like temperature outside. If I go from 31 degrees to 32 degrees versus 86 degrees to 87 degrees, both of those represent that single objective degree increase. If I'm doing a blood pressure measurement of 120 to 121 or 180 to 181, gosh, we sure hope not. But that single unit increase represents a single, millimeter movement of mercury. So in that particular case, again, those have an objective measurement and a definition of unit. So that's what we add to make a data interval. So again, private to private first class, that's one movement, a movement of one. 4 to 5-star general, that's also kind of a movement of one, but those ones are a very different size and meaning. Interval says the movement from 30 to 31 degrees is a movement of one. The movement from 86 to 87 degrees is a movement of one. And both of those movements of one have the same meaning. So that's interval, equal interval. The last type of data that we have is data that fall under ratio levels of measurement. Now, a ratio level of measurement points out that for interval data, there's no what's called true zero, TRUE, true zero. In ratio data, we add a true zero. So I want you to think about interval and our example of temperature. So with temperature, I used to live in Wisconsin, and it got very cold outside. And it would get down to 3 degrees, and I'd be cold. And then I'd get down to 2 degrees, and I'd still be cold. I'd get down to 1 degrees, and then I'd be very cold. And I'd get to 0 degrees, and I'd be very cold. And do you think it stops there? Well, unfortunately, it sure doesn't. It keeps going into negative degrees. -1 degrees outside, -2 degrees outside, and there are plenty of negative degrees that exist if you live in Wisconsin. So interval numbers do not necessarily stop at 0. In fact, interval numbers do not stop at 0. They do not have that property of what we call a true zero. Ratio numbers, on the other hand, do stop at 0. If you get on the scale, what weight do you see? That is considered a ratio number. Not only is there an order to two numbers, not only is the interval between any two distances the same, but there is a true zero. That is, you will never step on the scale and see a negative number. The ratio has a true zero. Good ratios are things like weight or things like height. Often the way that we measure physical quantities takes the form of a ratio scale. Again, where we can't have negative values, that it formally stops at 0. Now, each of these, interestingly, connect directly to the types of statistics that we can calculate with them. We'll talk about this more in a little bit when we jump into measures of central tendency. But for now, we can think of basic math operations. With nominal data, there really isn't any basic math operations we can do. In fact, even with ordinal data, I can put the information in order, but that's about it. With nominal, I can count how many things occur in each category. With order, I can count them and I can place them in a specific order. With interval data, though, I can start doing things like adding and subtracting the data. What ratio lets me do is ratio is what allows me to multiply and divide. So once I have ratio data, the ability to divide, that is, take the ratio between two numbers, is something that I gain with data with that level of information per data point. Again, it's important to realize that as each of these things happen, I get more and more and more information per data point. What does that mean to have more information per data point? Well, consider if I told you that someone had, um, let's break it down. Let's start with a ratio. Your grade in the class is a 92. Um, well, if I understand grades to be between 0 and 100, 0 is the bottom, then a ratio would tell me 92 is pretty good. It's near the top end of the scale, and it's far away from that bottom. Now, what if I told you it was a 92, but I took away your reference points, that 100 and 0? It's just a 92, but your grade could be negative, it could be positive, it could, as far as you know, it could be anything. Well, you actually lose a lot of information with regards to what that 92 means. So when I move from ratio to interval, I can lose a lot of information depending on the type of data I'm working with. Let's take it one step further back. I don't even tell you the number. I just say it was kind of high. You had a pretty high grade in the class. Okay, well, that's good. But could I do any math with it? Could I calculate a GPA from that? Absolutely not. Ordinal takes it even a step further back. Perhaps I even just told you got an A in the class. I guess they're both kind of the same. You got a high grade, you got an A in the class. In that particular case, you have lost information. Whereas I started with a 92, say out of 100, that was the ratio measurement. Letting me know I just got an A in the class, again, doesn't necessarily mean much as far as it relates to actually trying to figure out what grade I got. So I lost information moving backwards. Even a high grade, I guess in the formal example, if we wanted to play this out even more in depth, Ordinal would say it's an A, and I know an A is better than a B, but maybe there are things that are better than an A. Maybe you could have gotten an A plus. So where does that fall in that category? All right, so let's take it one more level back. Nominal. Nominal might say you got a grade in the class. So you have been graded. Your grade has been put in. So you fall into the category of people that have been graded, but there's not really an order to be put in. You don't really have much information outside of that. Now, when you hear me take away pieces of information, realize that all of this is the same data point, but expressed in a different level of specificity. To be set as a 92 on a scale of 0 to 100 is one level of specificity. To be set as a 92 without any levels of reference is a different level of specificity. To be set as an A is even a different level of specificity, and to just be told you have a grade is even a different level of specificity. With each of these losing information, that is, I'm being less and less and less specific. Note that as I get less specific, I'm forced to use less specific measurements and statistics in order to capture summaries about that data. So as I move higher and higher and higher into this, away from the R and closer to the N, I'm forced to use less and less specific methods. Note that while this sounds like a bad thing, and if you have lower levels, if you have ratio interval data, typically we as data analysts prefer to keep it at that level as opposed to making it ordinal or nominal unless absolutely necessary. Do understand that sometimes it's nominal and ordinal data is all you have, and that's okay too. So for instance, if I'm collecting information on patient gender or patient race in order to make conclusions about gender or race differences among a particular outcome, I can't really make that claim ratio or interval in any meaningful way. I don't want to say stuck with, but I am constrained by the nature of the data as it is. So don't feel bad if that's the case. That's not something to poo-poo in other people's research, and it's not something to be cautious about in yours. In fact, be confident if your measurement levels of measurement match what the variable is naturally. What I tell this to you to encourage you is that if you have a high level of measurement naturally, say interval or ratio, I encourage you to not reduce that down artificially. If you have an individual's age and ethically can maintain that data in a way that maintains proper data protection standards, then I would not take an individual's age and put it into a category. That is, I wouldn't say this individual is 27 years old and then group them as a 20 to 30-year-old. Because with the more information, we can calculate more specific statistics. Also, it's important to just realize pragmatically, I can always go backwards, but I can't go forwards. In that example I mentioned, I can always, at any later time, create a new variable, maintain my old data, never delete data, create a new variable called age group, and assign the 27-year-old to the age group of 20 to 30. But if I deleted the old variable and I start with the age group 20 to 30, I can't then go back to calculate that original age. So I can always reduce down the level of measurement, but I can never increase the level of measurement from data at a lower level of measurement. This is another reason that I maintain my data if my data protection standards allow at the highest level of measurement possible, because those data points, again, capture the most information and let me make determinations with the most precision. So while this level of measurements conversation is interesting and actually pretty vitally important in terms of what we can do to interpret and good to think through, more broadly in analytics, we tend to talk about bigger categories. And I say that somewhat pun intended. The bigger categories are categorical data and continuous data. Broadly speaking, nominal and sometimes ordinal are included in categorical data, and interval and ratio are included in continuous data. Now, I'll note that categorical data, as I mentioned here, tend to be categories. Continuous data tend to be numbers. What I'm noting is that continuous has a pretty mathematical definition that is not just numbers. So for continuous data in mathematics, we're required to have an infinite number of numbers. In a sense, it's actually even more technical than that. In statistics, typically we just say you have a fair amount of numbers. How old are you in years? We tend to treat continuously. How are you feeling today on a scale of 1 to 10, where people are answering in whole numbers? We tend to treat continuously. Because I guess in mathematics, a true continuous variable would be one where the decimal makes sense. This is in contrast to a discrete variable. Again, this is beyond the scope of this class. I apologize for digressing. More broadly, again, we have categorical variables, which are the categories. Again, nominal is the type of variable you're thinking of, favorite color, favorite pizza topping, favorite superhero. And continuous tend to be our numerical data. And we tend to talk about categorical and continuous variables more than we talk about the specific levels of measurement. This said, there are times when we do go back and have a levels of measurement conversation depending on the context and the interpretation that we're trying to apply. Again, this course being focused on interpretation, we need to have that level of specificity that we can go to where I can say this is an interval metric, and so that means we can't rely on the zero, and you understand what that means in context. Because sometimes we want to do a division problem. We want to take a ratio of two numbers. But if the measurement scale is interval, that ratio of two numbers does not make sense, and we're not able to do that and have a valid interpretation. Or said another way, if we do that, we can't interpret that value, and we need to have that red flag to be waving in our minds to say, actually, you just did a ratio of two interval numbers without true zeros. You can't divide those. That doesn't have any meaning. So that's the goal of introducing this. The other reason is because often we do use ordinal data. That Likert scale, strongly disagree to strongly agree, is very popular in many fields, including patient feedback. In medical contexts and many, many more components of medical contexts. So ordinal data walks a weird fine line between categorical and continuous. As these situations pop up, we'll discuss them more. I'll just say here that in ordinal, typically if you have many possibilities, so not just 5, strongly disagree, disagree, neutral, agree, strongly agree, that's a typical Likert scale, but maybe you have 7, maybe you have 10 options that people can choose from. The more options you have, the closer to continuous and the further away from categorical we tend to treat those values. Also, if you have multiple items and you take an average of them, that helps too in terms of the number of options that you have to take advantage of. So that also increases takes us closer to categorical than continuous. And typically, if you're taking the average of multiple ordinal items together, we treat that average score, sometimes called the scale score. If you took an average of 5 items that are meant to go together on a scale, we'll call that the scales score, or the sum of 5 items that are meant to go together. We tend to treat that as continuous. There are statistical methods that do treat ordinal data as specifically ordinal. Those are mostly going to be beyond the scope of this class, so we'll avoid them. But do realize that they are out there. They do exist. They do have a bit more of a technical interpretation, though. All right, so let's go through a couple of types of examples, see if you can correctly identify some of these. So given our discussion, actually, again, this will be a great opportunity. I'll pull up a couple, try pausing the page and seeing what you can get. So let's try this one. So number of raindrops on the roof. Is that nominal, ordinal, interval, or ratio? Go on and pause and then come back. Actually, you know what? I'm just going to display all of these. There we go. So for each of these, go on and pause the video, look at each of these, and then come back and after you've paused it and thought about them, and we'll talk through them. All right, coming back. So number of raindrops on the roof. Well, in levels of measurement, number of raindrops, that does have a true 0. So that's looking like a ratio value to me. This is something that does not always have a middle. So it's not mathematically continuous, but in statistics, we would probably treat this as a continuous variable. But again, there's no half raindrops. So mathematically, this would be called a discrete variable. But we would probably treat this as continuous, and again, ratio because it has a true 0. Temperature outside, well, we actually used this one in our example earlier. I got to stop doing that. Believe it or not, I don't know that this is going to say that when I give my examples. But temperature outside, this is one that's going to be interval because it doesn't have that true 0. And it doesn't really matter what Fahrenheit, Celsius, it doesn't have that true 0. Of course, if we talk about Kelvin, it's a bit of a different story, but we'll skip that. Okay, so temperature, we'll call it interval. Favorite superhero. Now, this is interesting. Well, favorite superhero is going to clearly be a nominal variable. I forgot to mention categorical continuous for temperature outside. Continuous for temperature outside. Favorite superhero is going to be a nominal variable. They don't go in order. I mean, clearly Thor is better than everybody else, but outside of that, they don't go in order. There's no inherent order to it. So we would have favorite superhero be nominal. Score in class from 0 to 100. Well, because we have the 0, that's going to be a ratio measurement. So it's a score in class. Excuse me. I'm sorry. I keep forgetting. Favorite superhero, categorical. So it's nominal and then would be categorical. Score in class from 0 to 100. Well, we would consider that probably to be ratio. You know the scale. It's got a 0 in it. So that would be a ratio metric, and we would treat that as continuous. Scoring class is a letter grade. Oh, that's kind of interesting. So scoring class as a letter grade is going to be ordinal, right? Because we know an A comes after a B. So there is an order. It's not going to be nominal. But the difference between an F and a D is very different than the difference between a B and an A, right? Fs tend to be 0 to 60, and Ds tend to be 60 to 65. Whereas Bs are 80 to 89 and As are 90 to 99 or 90 to 100. So the distinction there, F to a D is a very different jump than a B to an A. So this would definitely be ordinal. However, now I say that, and that's the traditional way we'd think about this, ordinal as scoring class. but there is kind of a counterexample here that would say that this is a ratio measurement. And that counterexample is your GPA. So if you think of your GPA translates an A as a 4, a B as a 3, a C as a 2, a D as a 1, and an F as a 0. It does have a true 0, and then it calculates and it does some multiplication with this in your credit hours to calculate your GPA. So in your GPA calculation, score in class as a letter grade is taken as ratio, even though how we normally think of it, A, B, C, D, F, is taken as ordinal. Because again, because the F category is different than the rest of them. So that's what makes it ordinal rather than ratio when we think about it normally. I guess one last point on these last two, score in class. This is kind of an interesting couple examples. I like this. Because score in class, what this is showing is that the same concept can be operationalized differently. I think at the end of the last video, we talked about operationalization. And again, if you didn't write that down and you didn't see that in the last video, write this word down. It's a very important thing in research. I try to give you a lot of notes, but I do leave a couple of gems out there because I want you to get these. I want you to be watching the videos. I want you to pick up on these concepts. Operationalization. Again, how are you measuring that? How are you getting that? This happens all the time with like intelligence. I want to see if being a Mac user versus a Windows user, which one has more intelligence? Well, how do you operationalize intelligence? You could use an IQ test, you could use an EQ test, etc. But a bad operationalization of intelligence is giving somebody a Windows exam on how to use a Windows machine and saying, oh, well, people who score high are intelligent, people who score low aren't intelligent. That's a very biased operationalization of intelligence given the research question. So here, we're operationalizing the same concept, score in class, in two different ways. The first one is a clearly ratio measurement, the numeric 0 to 100. The second one is a pretty clear ordinal measurement, A, B, C, D, F. And both of those are valid operationalizations, but the top one has more information. So again, as I said before, I would tend to keep the one with more information if I have the data security to maintain those records. Ethically, I always want to keep the ones with more information. And then if I want to, I can always make a new variable for the variable with less information for reporting purposes or for research purposes, if that better links to somebody else's analysis, or if I just need to go to the one with less information to be able to do my analyses in the first place. But I always maintain the record with the most information so that if I am able to use an analysis that incorporates that information, I can, because again, those analyses are going to give me much more precision than other types of analysis. All right, well, this has been our second video in this lecture set. In this video, we talked about some different kinds of variables and some different examples in that. In the next video, we are finally going to jump into some calculations. I know you've been waiting with bated breath. So we're going to jump into some calculations on measures of central tendency. I think you'll find they go a little bit faster because they're a little bit less theoretical and a little bit more concrete. Maybe that's a good thing for some of you. Maybe it's a bad thing for some of you. But either way, we're going to be jumping in the next video of this lecture set. So I look forward to seeing you then.